With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, our question is, we are given with arrangement of star shaped resistance system, and if the resistance of each branch of the circuit shown below is 1 omega, which is 1 ohm, then the equivalent resistance of the circuit between point A and B is, and this is what we have to find. So first we analyze our star arrangement. So we see here that we can find the equivalent of this area. Okay, and similarly we can also find the equivalent of this area because it is a simple arrangement. If we see only this part, this triangle part, which I am highlighting, and similarly for all the triangles which are present outside, like this one, and like this one, and they have same resistance. Why? Because they are all same resistance, or we can say similar type of arrangement. So we name it as R equivalent 1. So it will also be R equivalent 1, and the others will also have the same value because they are similar. Let me name it them one by one. So they have same value. How are we gonna find this? We know this is 1 ohm because each small wire have 1 ohm resistance. This will also be 1 ohm and this will also be 1 ohm. So we see here it is simply a series combination. So 1 and 1 will become 2 and it will be parallel with 1. So our R equivalent 1 will be, it is 2 and this is 1, so it will be 2 into 1 upon 2 plus 1. We are finding R equivalent in this way because they are in parallel arrangement. Okay, so our R equivalent 1 will be how much? It will be simply 2 by 3. So the same value is for all such arrangements, and there is one more rule. Basically it's a law, or we can say general knowledge, that the center of symmetry will become open like this. This will connect it to this and this will connect it to this. Okay, because there will be no transmission of current through this node. Okay, the current in this area will remain on this side and the current in this area will remain on this side, so we can consider it as open. Okay, this is from the law of symmetry of resistance. So I'm not writing the law, but I have stated it. So if we do the diagram of the arrangement after the opening of node, so let me draw it. It will be like this, and another shape, yeah, like this, and there will be lines here and also here. There is one thing, this junction is open now, like this, and on the above two, like this, and there is a resistance of 1 ohm and a 1 ohm, that is 2 ohm in the middle, like this. Okay, this will be like this, sort of like this, and this will be our A and this will be our B. Okay, so this resistance will be how much? It will be 1 plus 1, it will be simply 2 ohm. Okay, and our this resistance will be equal to R equivalent 1. This will also be equal to R equivalent 1. This will also be R equivalent 1. This will also be R equivalent 1. This will also be R equivalent 1. And this will also be R equivalent 1. And this will be simply 1 and 1. And this will also be 1 and 1. So we have simplify our diagram. So now if we calculate it, so R equivalent is 2 by 3 and this will be 2. So the parallel arrangement of 2 and 2 by 3 will be simply how much? Let me find it. We name it like this whole arrangement will be what? R equivalent to, and this also be equal to R equivalent to. So our R equivalent to will be how much? It will be R equivalent to, it will be equal to 2 and R equivalent 1, which is 2 by 3 into 2 divided by 2 plus 2 by 3. So its value will be, the above will be, numerator will be 4 by 3, and in the denominator it will be how much? 6 into 8 by 3. So it is coming 1 by 2 ohm. So R equivalent will be how much? 1 by 2 ohm. So here this R equivalent 1 and R equivalent 1 will be in series. So it will be 2 R equivalent 1. So it will be simply now how much? 1 2 times plus R equivalent 2, and this is our RT dash. And what is RT dash representing here? This whole arrangement. Okay, and another this arrangement. So it is our RT dash, and it is also RT dash because they are similar. So our RT dash is simply this much, and our RT dash will be 2 into R equivalent 1, which is 2 by 3, plus R equivalent 2, which is 1 by 2. So it will be, if we simplify it, we have to take the LCM. So it will be 4 by 3 plus 1 by 2. So LCM will be 6, and it is 4 by 3. So 2. So it will be 8 plus how much? 3. So it will be 11 by 6. Now we have to find R equivalent for the whole arrangement, and it contains only 3 resistance. One is 2 ohm and other 2 are 11 by 6. So when the two equal resistance are in parallel, so their value become half. So 11 by 6 and 11 by 6. So it will be half of 11 by 6, which is, let me say it as RT double dash. So it will be 11 by 12, and 11 by 12 is parallel with 2 ohm resistance only, which is this much. Okay, so our RAB, so we write RAB is nothing but the parallel combination of the resistance 11 by 12 and a 2 ohm resistance. So we find it like, we find the R equivalent for parallel arrangement. So it will be 11 by 12 plus 2, like this. And if we simplify it, it will be 11 by 6, and in the denominator it will be 24 plus 11, which is 35 by 12, and its value will be how much? It will be 6 divided by 12, so it will be 2. 2 goes on numerator, so it will be 22 by 35 ohm. And this is the value of R equivalent between A and B. So this is our answer, and our correct option will be which one? B1. Okay, this question is completed here. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.